Hi. When people learn that I have a YouTube channel, they sometimes ask, what is its name? To which I say, it's called LifeLoveAndMonads. They say, Life, Love, and what? I say, Life, Love, and Monads. What are monads, they ask then. That's a great question, I say. Let's talk about what are monads in this video. But first, the textbook definition of what monads are from the category theory is that the monads are monoids in the category of and the functors of some fixed category. But I honestly have no idea what that means. If you know what that means, stop watching the video immediately because I don't want to embarrass myself in front of you. But otherwise, this definition has no meaning for us practical programmers. Yet at the same time, if you use JavaScript daily, then you use monads all the time without calling them monads. Look at this guy, for example. We can say this is a monad. And here is another one. So I believe the best way to understand what monads are in the practical sense is to understand what functors are in the practical sense. So what are the functors? Functor is basically an interface, and in order to implement this interface, a type that wants to be a functor needs to implement a function map that takes another function from some value t to some value r, and then will apply that function to every element inside the functor. So basically, the functor is a value that is wrapped in some context, and then we can apply a function to the value inside that context. So we get a new context with a new value inside. With that in mind, we know that JavaScript array implements function map. It has a little bit different arguments, but essentially it does the same thing. So if we have an array of 3 numbers, those numbers are inside the context. So we can use function map to apply some other function to every element inside that context. In this case, increment each value by 1, hence producing a new array where each number is incremented by 1. We can also chain those map functions, but unlike in object-oriented programming, when you need to implement an interface, it just says that you need to implement a particular method, but it doesn't really apply any rules about how this method have to be implemented. Functor essentially comes with a 2 laws attached to it, and your implementation need to obey those laws. Law number 1 is identity law, meaning that if we map an identity function over functor, then the result will be exactly the same functor. Identity function returns value itself. So now if we create a new functor, we will see that it will be functor 1, 2, 3, meaning essentially this is exactly the same functor as it was before. Of course, there will be 2 different arrays sitting in 2 different places in memory, and they have different references, but from the abstract perspective, they are exactly the same. The second law of the functor is composition, meaning that mapping a composition of the function over the functor values will produce exactly the same result as we're going to map one function first and then the second function map over the result of the first function. Say we have 2 functions. First one increments value by 1. Second function brings the value to the power of 2, which means that mapping f first over the array and then mapping g over the result would produce exactly the same result as if we would map a composition of those 2 functions over the value. So since the array implements a function map that obeys those 2 laws, identity and composition, we can say that JavaScript array is a functor. This is where you can rightfully say, but what about monads? Isn't this video about monads? Yes. So now since you understand what functor is, we can now talk about what monad is. And monad is just another interface. But this time it's interface that requires implementation of 2 methods. First of them is method of that takes some value and wraps it in the context. In functional programming, it's often called lift. The other method is basically flat map. Flat map is like map, takes function and applies that function to every element inside the context. Except that this time the function doesn't just return value, it returns that value wrapped into a new context. So let's see if array is a monad. Array has method of that takes some value and wraps it in the array context. It also has a method flatMap that can take a value, wrap it into context, and get flattened result back. Here we see that original values were incremented by 1, yet at the same time we didn't receive a context within values wrapped in context wrapped in another context. They are wrapped in the context only once. And this is what flat map is good for. As with Functor, Monads flat map implementation should obey two laws: the left identity law and the right identity law. Left identity law basically says that if we take some value and lift it into a Monads context and then flat map it with a function, we should receive exactly the same result as if we would just apply same function to a value. Let's say we have a function that takes some x and then returns an array of x plus 1. So here if we have an array of 1 and we flat map it with the function f, it produces exactly the same result if we just call function f passing 1, which means that the flat map function obeys the left identity law. The right identity law says that if we flat map some monad with a constructor, in this case it's array of, we will get exactly the same result as the original monad, which means that the right identity holds as well. So everything that is a functor can also be a monad. And we just demonstrated that the JavaScript arrays are essentially both functors and monads. Another interesting example of monad that you use all the time is promise, except that promise, instead of having method of, it has method resolve, and instead of flat map, it has method then. Let's see if then obeys the laws. So let's take a function that does basically this. Now if we take a promise and apply to it the function f, it will be the same as applying function f to a value that promise was resolved with. In this case it's 1 that in both cases produced 2. We need to write this code in order to get access to that value hidden inside the promise context. So the left identity law stands. What about right identity law? For the right identity law, we said that if we flat map with the constructor function, we will get same monad back. If we do promise.resolve 1, then promise.resolve, and then promise.resolve of that value, we will get 1 again. So we resolve to the same essentially promise, meaning that promises are also monads. So why am I telling you all of this? I'm telling you all of this because it's really cool to brag about when you understand monads. Not on the theoretical sense, but if you can brag about that, you are way cooler than me. But disregarding the fact that monads are so complicated on the theoretical sense, on a practical sense, they are very simple. And the second reason is that there is one secret additional law of monads. When you understand what monads are, you need to tell other developers your understanding of what monads are. Thank you for watching.